Hi everyone. Today in this video we are discussing about the valid Sudoku problem. If anyone ever played the Sudoku game, there will be known of rules. If you don't, you need to know the rules to solve this problem. In this puzzle, there will be 9 cross 9 box. In each box there will be a number. For this problem we need to only tell that the Sudoku is valid or not. We need not to fill the values in this. So each row will contain 9 to 1 to 9 numbers only, 1 2 3 like 9 each column, and 3 cross 3 boxes are there. The rule number 1 is that we take a row. See this, if we take a row number 0, the 5 should not be repeated in every column. If it is in this column, the 5 should not be there in this row again. So we need to validate that the number should not be repeated in the same row and column as well. If there is be 5 in this, the column number 0 should not contain 5 again. This is number rule number 2. And the rule number 3 is that if we take 3 cross 3 box like 0 1 2 3 cross 3 box, the number should not be repeated in this box also. Like if we had 9 in this box, these 4 spaces should not contain 9. So the empty spaces will be filled with dots. So we need to validate with the numbers only in this problem. Firstly, if we go into the approaches, the first approach we think is that take the one number and check with the all numbers in the row and in the column as well as with the box itself. So each row contains n elements, which is 9. We need to check each number with the 9 other elements in the row and in the column. In the box also there will be 9 numbers. So the time complexity for the checking with the other numbers could be 9 into 9 into 9, which is n cube. For the brute force approach, there could be a n cube, but it will definitely give us the correct solution. When we go into the optimal solution, can we imagine rather than checking with the all elements each time, which are repeated checkings, can we store the number which is already checked like that in true or false? If we take a Boolean array and take 5 and check with the other numbers. If there is a 5 in that array, the 5 is repeated. So we can directly return false, which is invalid Sudoku. We can take each array for the row as well as column and the boxes. The boxes values can be calculated as P2023 is one box and 326 629. These are the row boxes and the for column also 0 to 3, 3 to 6 like that. We give firstly 0 to 0, it will be in this box. After that plus 3, like go into the next box. We will just add the 3 and reiterate R until the next box. So we can also check the boxes as well. The better solution is using the arrays. We can store the elements which are visited and not visited as true or false in the Boolean arrays. Like if we take all this input is given as the character, so if we take 5, the 5 should be represented in ASCII value, like for 0 48, 49 50, so 53 or 54 for the 5. We simply subtract the 1 from the character get which is checking for the row or column or box. Simply my we simply subtract the element from the 1, then it will be stored at the index of 0 to 9. Whenever we get another element, we firstly check the element is the matching or not with this number. If it is already true, it is visited, and once again it is coming, so it is invalid Sudoku. Like that, we need to implement the row checking, column checking, and the box checking. The Sudoku will be explained next.
Now we check the valid Sudoku follows all the rules or not. The idea of this solution is to check whether the Sudoku board follows all the rules. We do this by checking rows, columns, and 3 by 3 boxes separately. If we find any duplicate number, the Sudoku is invalid. Now we check rows. First, we check each row one by one. For every row, we keep a boolean array to remember which number have already appeared. As we move through the row, if we see a number that was already seen before, it means the row is invalid and we return false. If we finish checking the row without duplicates, the row is valid. Now we're going to check columns. Next, we check each column. The logic is the same as row checking, but we move vertically instead of horizontally. Again, if a number appears more than once in a column, the Sudoku becomes invalid. Next, the 3 by 3 boxes checking. After rows and columns, we check the 3 by 3 boxes. The Sudoku board contains 9 such boxes. For each box, we scan all 9 cells inside. We use the same idea of remembering already seen numbers. If a duplicate number is found inside any box, the Sudoku is invalid. We know if all rows, columns, and 3 by 3 boxes are valid, then the Sudoku board is valid, and we return true. Now check the time complexity and space complexity of this problem. Now we are going to discuss time complexity and space complexity. The Sudoku board size is always fixed at 9 by 9. So the number of checks we perform is constant. So the time complexity is O 1. Now the space complexity. We only use a small Boolean array to track numbers. Its size is fixed and does not depend on input size. The space complexity is also O of 1.